Good afternoon to everyone. I am Anil Kumar, chemistry lecturer. In my previous video, I explained about hybridization by using some simple tricks. So, in this particular video also, I am explaining the topic hybridization in that, see, molecule containing multiple bonds. In my previous video, I explained how to calculate the hybridization in molecules which are not having multiple bonds, in this particular case the molecules which are containing multiple bonds. See, note, so trick is nothing but, trick is very simple. Trick, number of sigma bonds plus lone pairs. Total number of sigma bonds plus total number of lone pairs, it gives a type of hybridization. If only sigma bonds, we should consider only sigma bonds in hybridization. See, note, do not consider pi bonds because hybrid orbitals always form only sigma bonds but not pi bonds. That's why in calculation of the hybridization we never consider the pi bonds. So trick is nothing but number of sigma bonds, it gives hybridization, or number of sigma bonds plus if lone pairs are present in that particular molecule, we should consider total number of lone pairs, it gives a type of hybridization. See, I am going to explain hybridization in few molecules. First one is nothing but SO2 molecule. SO2 molecule. Hybridization in sulfur. Sulfur is a central atom, belongs to 6th A group. So it is having total 6 valency electrons. See, sulfur is having 1, 2, 3, 4, 5, 6 valency electrons. In that, 2 electrons are bonded with 1 oxygen. 2 electrons are bonded with 1 oxygen atoms orbital form 1 sigma bond, 1 pi bond. And another 2 electrons bond with 1 oxygen and form 1 sigma bond and 1 pi bond. And lone pair of electrons are present, 1 lone pair of electron. So here we should consider only sigma bond and lone pair. See, number of sigma bonds, 1 plus 1, 2 sigma bonds, plus number of lone pairs, how many? 1 lone pair. So it gives 3. 3 means sp2 hybridization. We should consider this is S, this one is P and this one is P. sp2 hybridization. If total number is 3, it means sp2 hybridization. I already explained in my previous video. If numerical 2 is there, then hybridization is sp. If number 3 is there, then hybridization is sp2. If 4 means sp3, 5 means sp3d, 6 means sp3d2, 7 means sp3d3, like that. So we should consider what? Only sigma bonds but not pi bonds. Sigma bond but not pi bond. Number of lone pairs. So here total number of sigma bonds 2 and number of lone pairs 1 lone pair, 2 plus 1 3 means sp2 hybridization. So in SO2 molecule sulfur atom undergo sp2 hybridization. Next, in case of SO3, 1, 2, 3, 4, 5, 6 electrons are valence electrons are present in sulfur. 2 electrons, another 2 electrons bond with oxygen to form 1 sigma and 1 pi bond. So here, total number of sigma bonds are 3. 3 means sp2 hybridization. We should consider sp2 hybridization. In SO3 molecule, sulfur heteroatom undergo sp2 hybridization. Next, example 3, xenon trioxide. Xenon trioxide. Xenon is a central atom which contains 8 valency electrons. How many? 8. See, xenon 1, 2, 3, 4, 5, 6, 7, 8 valency electrons. In it, 2 valency electrons are bonded with 1 oxygen atom's orbital and form 1 sigma bond and 1 pi bond. Same like these two also form 1 sigma, 1 pi. These 2 electrons form 1 sigma and 1 pi. One lone pair of electrons are present. See, number of sigma bonds 1, 2, 3. Number of sigma bonds are 3 plus number of lone pairs 1 is equal to 4. 4 means sp3 hybridization. Okay, 2 means sp, 3 means sp2 hybridization, 4 means sp3 hybridization. sp2, sp3 hybridization. Now, I am going to take another example. Xenon tetraoxide. Xenon tetraoxide. Xenon is a central atom which is having 8 valence electrons. In the 2 valence electrons are bonded with 1 oxygen. Like the total 8 electrons bond with 4 oxygen atoms to form what? Sigma and pi bonds. How many sigma bonds are present here? 1, 2, 3, 4. 4 sigma bonds. How many? 4 sigma bonds. So 4 sigma bonds means 4 means what? sp3 hybridization. In xenon tetraoxide, xenon tetraatom undergo sp3 hybridization. Okay. So our trick is related to molecules which are containing multiple bonds. We should always consider the sigma bonds to calculate the hybridization, but not pi bonds. But not pi bonds. I am going to take one more example. In case of CO2, carbon is a central atom which is having 4 valency electrons. Carbon is a central atom which is having 4 valency electrons. In the 2 valency electrons are bonded with 1 oxygen to form 1 sigma, 1 pi bond. Another 2 bond with another oxygen to form sigma and pi. We should consider only sigma bonds. Number of sigma bonds 1 plus 1. Total number is 2. 2 means sp hybridization. So in CO2 molecule, sp hybridization is present. Why? Because total number of sigma bonds are 2. hybridization in ions. Hybridization in ions. See, so many ions are present. For example, ammonium ion and hydronium ion, nitrate ion, carbonate ion, like that. So many ions are present. Sulfate ion. Okay. So here I am going to calculate the hybridization of central atom in that particular ion or charged species. I am taking ammonium ion, ammonium ion. See, in that nitrogen is a central atom. In that nitrogen is a central atom is having 5 valency electrons, but plus charge indicate one less electron which is present in nitrogen. So total number of electrons are nothing but 1, 2, 3, 4. One is nothing but plus charge. One is plus charge means there is no electron is present. So total number of valence electrons in nitrogen is 4. So these 4 electrons bond with 4 hydrogen atoms s orbitals to form what? 1, 2, 3, 4. 4 sigma bonds. Means 4 means what? sp3. 4 means sp3 hybridization. So total number of sigma bonds, that is equal to a type of hybridization. In ammonium ion, 4 sigma bonds. One electron is bonded with one hydrogen, one sigma bond. Second electron bond with another hydrogen atom s orbital to form one sigma bond. Like that, 4 sigma bonds are formed. So total number of sigma bonds are 4, means hybridization is sp3 hybridization. I am going to take another example to explain the hybridization by using number of sigma bonds and lone pair of electrons. So here hydronium ion H3O plus, in that oxygen is a central atom. Oxygen is having actually 6 valency electrons, but that plus charge indicates one less electron in that particular oxygen. So here I am keeping plus means one less electron. Okay, so here 1 electron, 2, 3, 4, 5. So total 5 electrons are present. Okay, so in the 5 electrons, this electron is bonded with hydrogen to form sigma bond. Second one form sigma bond. Third one form sigma bond. 2 electrons, lone pair of electrons. This is nothing but lone pair of electrons. So number of sigma bonds are nothing but 3 plus number of lone pair of electrons are 1. So 3 plus 1 is equal to 4, means sp3 hybridization. It means what? sp3 hybridization. Okay, so this is about the hybridization and few simple tricks to learn or calculate the type of hybridization in a central atom of a molecule or charged ion. Okay, so 2 simple tricks here. One is calculating the number of sigma bonds, and second one calculating the number of sigma bonds and lone pairs. And notice nothing but neglect the or does not consider the pi bonds which are present in that particular molecule. Why? Because hybrid orbitals always form only sigma bonds, so you should consider only sigma bonds in this particular hybridization. So I hope everyone please like this particular hybridization concept, comment and subscribe my YouTube video channel. Thank you very much.